Hello students, welcome to the world of this three-dimensional geometry. Today we'll be discussing direction cosines of a line. Throughout this chapter we talk about direction cosines of a line. If you don't have the correct idea of a direction cosines, then you can't understand a single concept of this three-dimensional geometry. So let's begin. What do you mean by direction cosines of a line? Before moving on to direction cosines of a line, first let's understand what are directed angles. Let us see here. So this is the coordinate system. This is x-axis. You treat it as a y-axis. This as a z-axis. Doesn't matter if you take this as the x-axis, this as a y-axis, this as a z-axis. You can rotate this coordinate axis according to your wish. So let us, right now you suppose that this is your x-axis, this is your y-axis and this is your z-axis. Before moving on to direction cosines of a line, let's understand directed angles. Here is a coordinate axis. This is your x-axis, this is your y-axis, this is your z-axis. Now suppose if the line makes certain angles with x-axis, y-axis, z-axis. See here. This is a line making certain angle with x-axis. Here. And we call this angle as alpha. Means the angle between a line and x-axis is called alpha. Similarly, this line makes an angle beta, certain angle with y-axis, and this angle is called beta. And the angle between this line and z-axis is called gamma. So if a line makes alpha, beta, gamma with coordinate axis x, y and z respectively, then the alpha, beta, gamma are called directed angles of a line. So let's see here. Now let us try to understand with the help of this figure. So here is a three-dimensional space and coordinate axis x-axis, y-axis, z-axis. So here is a line in space or line passing through origin. Now it makes an angle alpha, beta, gamma with x-axis, y-axis, z-axis. Look at this angle. This angle is alpha between x and this line. The angle between the line this and y-axis is represented by beta. Similarly, the angle between z-axis and this line is gamma. So these are called directed angles of a line. So directed angles are the alpha, beta, gamma, which are made by the line with x, y and z axis. So remember that whenever alpha, beta, gamma comes in this chapter, they are nothing but directed angles. So let's move on to very important, that is direction cosines of a line. So let's see here. Okay, as we know that alpha, beta, gamma are the directed angles. So if alpha, beta, gamma are the directed angles, then cosines of those angles are called direction cosines of a line. Very simple. So direction cosine, the name itself indicates. Cosine means the the cosines of the directed angles or directional angles are called direction cosines. So if alpha, beta, gamma are the direction angles, then cos alpha, cos beta, cos gamma are called direction cosines, and they are represented by LMN. So whenever LMN comes, you can treat or bring in your mind they are the direction cosines. So L stands for cos alpha, M stands for cos beta and N stands for cos gamma. So in this way you have to remember what do you mean by direction cosines, and we will have one important, beautiful, simple relation between direction cosines. Now the question is, what about the direction cosines of parallel lines? If the two lines are parallel, then what about their direction cosines? Remember that if two lines are parallel, then their direction cosines are same. See here, there is a one line in space, and if I draw line parallel to this passing through origin, if I draw a line parallel to this passing through origin, now you can find what are the angles made by this line with x, y, z axis, and you can find the cos of the angles. So whatever the direction cosines of this line will be the direction cosines of this line. So if two lines are parallel, then remember that their direction cosines are also same. Very important things to be noted. Now see here is the line RS as I mentioned, and there are two more lines here and they are parallel to each other. So in this case, the direction cosines of all the three lines are equal. So remember. Now as I said here only, the question is how to find the direction cosine of a line that does not pass through origin. If the line is somewhere here in space, remember that. Okay, see here. This is a line in space and I want direction cosines of this line. Look here. This is a line somewhere here in space and I want direction cosines of this line. So what to do? Use the previous property. As I said, parallel lines will have the same direction cosines. So in such case, you have to draw a line parallel to this passing through origin and find the direction cosines of that line. So you have to draw a line parallel to this and passing through origin. So like this is the line parallel to the given line in space, and find the direction cosines of this because it makes certain angle alpha, beta, gamma with x, y, z axis. So if you find the direction cosines of this line, then those are nothing but direction cosines of this line in space. So remember this basic thing. So in order to find direction cosines of a line that is in space, you have to draw a line parallel to that line passing through origin, and you have to find the direction cosines of this line that gives you direction cosines of given line. We will have one important and simple and interesting property of the direction cosines of a line. So let's see here. So if LMN are the direction cosines of a line, then the sum of their squares is always equal to 1. That means cos square alpha plus cos square beta plus cos square gamma is always 1. So remember this property, and if you are interested, let's see the proof of this property. So consider a line in space RS making an angle alpha, beta, gamma with coordinate axis. So you might be thinking of the line in space and how can it make alpha, beta, gamma with x, y, z axis. So it is equivalent to a line parallel to this RS making angle alpha, beta, gamma with x, y, z axis. Okay, so angle made by this line with x, y, z axis is equivalent to the angle made by the parallel line with RS with x, y, z axis. So let's understand the concept. Now here we have drawn a line L parallel to x axis, and alpha is the angle between L and x axis, as we have taken alpha as the angle between RS and x axis. Now L, M, N are direction cosines, so L is equal to cos alpha, M cos beta, N as cos gamma. Now see here, Take any point P on the line L and draw PA perpendicular to X axis. Now what will happen here? From this, by the distance formula, the distance between O and P, by the distance formula, square root of x2 minus x1 square, y2 minus y1 square, z2 minus z1 square. So here this is 0, 0, 0. So if you apply distance formula, you will get square root of x square plus y square plus z square. And if you square on both sides, so you will get r square is equal to x square plus y square plus z square. So remember the distance between O and P. Now in a triangle, compare this, see here this triangle OAP. And what about cos alpha? Cos is adjacent by hypotenuse. So this distance is x, because looking at the coordinates of the point P has the coordinates x, y, z. So this distance stands for x and this stands for y. So because this is along y axis, so this distance is x. So from the triangle OAP, cos of this angle is adjacent by hypotenuse. So cos alpha is adjacent is OA and hypotenuse is OP. So you can write OA by OP, and OA is your x and OP we have taken as a r here. So substitute here. So cos alpha is equal to x by r. So similarly, if you rotate the coordinate axis, okay, so what you will get if you take this as a y and this as z and this as x, and if you draw perpendicular, you will get cos beta is equal to, okay, y by r, and cos gamma is equal to z by r. And simply squaring and adding these three quantities, you will get this. So if you square and add, you will get r square common everywhere. We have r here, we have r here, we have r backside. So x square plus y square plus z square in the numerator, in the denominator you have r square common. So as we know that x square plus y square plus z square is nothing but this distance between this OP. Okay, so this is your r square. So let's see here what you will get, r square by r square. This is your r square. R square by r square 1. Okay, so this is the important property to be remembered, that is the sum of the squares of direction cosines is always equals to 1. So let's move on to some of the examples. Simple one, interesting one. So think of the direction cosines. So here is one example. If a line makes angle 90 degree, 30 degree, 60 degree, 30 degree with the positive direction of x, y and z axis respectively, find the direction cosines of the line. So direction cosines are given by L cos equal to cos alpha. So these are the given angles are nothing but alpha, beta, gamma. So alpha is 90, beta is 60 and gamma is 30 degree. So substitute here cos alpha, cos beta, cos gamma. So cos 90 degrees 0 degree 0 and beta is 60 degree. Cos 60 degree is 1 by 2 and gamma, cos gamma is cos 30 degree, that is root 3 by 2. So remember how to find the direction cosines of a line from given angles. So let's have one more example here. If a line makes 90 degree, 135 degree, 45 degree with a positive direction of x, y and z axis respectively, find its direction cosines. So let's given what? This is alpha, this is your beta and this is your gamma. So L is equal to cos alpha, that is cos 90, which is 0 as earlier, and you have a problem with this. Beta is 135 degree, so cos of 135 and cos of 135 you have to convert or express in terms of allied angles, means in terms of 180 plus 180 minus or 360 plus 360 minus. Okay, so 135 degree can be written as 180 degree minus 40 degree, and we know that cos of 180, that is cos of 180 minus theta is minus cos theta. These things have to be remembered. Without the fundamentals or basic concepts, you cannot solve a single problem. And never ever try for shortcuts, because that never helps you. So understand the concepts thoroughly, then you can crack any example. So let's see here. So cos of 180 minus theta is minus cos theta. So same thing here you have to apply. You can write this as minus cos 45 degree and minus, as it is cos 45 degrees, 1 by root 2. And last but not the least, that is n is equal to cos gamma. So cos gamma is cos 45 and cos 45 is 1 by root 2. So let's one more. So these are the direction cosines. 0 minus 1 by root 2, 1 by root 2. Find the direction cosine of a line which makes equal angles with the coordinate axis. Again, one of the important problem. There is a line which makes equal angles with coordinate axis. Means alpha, beta, gamma are all equal here. So using this concept, let's try. So here given are what? Alpha is equal to beta is equal to gamma, because line makes equal angles. So if the angles are equal, then cos of those angles are also equal. So here is cos alpha, cos beta, cos gamma. We have the property sum of the squares of direction cosines is always equal to 1. So cos square alpha, cos square beta plus cos square gamma is 1. And we have alpha is equal to beta is equal to gamma. So you can replace these in terms of alpha. So this can be written as cos square alpha, even this can be written as cos square alpha is equal to 1. So cos square alpha, cos square alpha, cos square alpha, 3 cos square alpha. So transfer 3 this side. So cos square alpha is 1 by 3. Therefore cos alpha is plus or minus 1 by root 3. So direction cosines are plus or minus 1 by root 3, plus or minus 1 by root 3, plus or minus 1 by root 3. So let's have one more example. Either you have to take one set plus or minus, because a line will have unique direction cosines. So what are the direction cosines of coordinate axis? Means what are the direction cosines of x-axis? What are the direction cosines of y-axis? And what are the direction cosines of z-axis? Let's see here. So here is the coordinate axis. The angle between x-axis and x-axis is what? X-axis makes 0 angle with x-axis. So here alpha is 0. Beta is what? Angle between x-axis and y-axis is 90 degree. Gamma is angle between x-axis and z-axis is also 90 degree. So direction cosines of x-axis are cos 0 degree, cos 90 degree, cos 90 degree. Okay, so x-axis makes 0 angle with x-axis, 90 degree with y-axis and 90 degree with z-axis. So therefore alpha, beta, gamma. Alpha is 0, beta is 90 and gamma is also 90. And as we know that cos 0 is 1, cos 90 is 0. So you have this. Similarly, direction cosines of y-axis. Y-axis makes 90 degree with x-axis. So alpha is 90 here. Beta means angle between y-axis and y-axis itself. So it is a 0 degree. So angle between y and z-axis is 90 degree. So it is a gamma here. So you have the direction cosines of y-axis as 0, 1, 0. Similarly out here. So remember that direction cosines of x-axis are 1, 0, 0. Don't remember. Remember theoretically, conceptually. Direction cosines of y-axis 0, 1, 0. Direction cosines of z-axis 0, 0, 1. So this is all about how the direction cosines of a line can be obtained, and in the next class we'll be studying the direction ratios of a line and relation between direction cosines and direction ratios. So let's till then take care.